Arc length. The way to describe an arc length is to draw a circle. So I'm going to draw a circle. With a circle drawn, I'm going to draw a radius from the center of the circle to any part of the circumference. So that's a radius. I've drawn a radius there. That line is a radius from the center of the circle to the circumference. I'm going to draw another radius. Right, so what I've done now is I've created a minor sector and a major sector. So this point is the center of the circle, labeled that O, and this is A, and that's B. The portion, if I just write the portion A, B, O, A, B, O is what we called a minor sector. So that's a minor sector. And what about A, the length A all the way to B, AB? That is basically a major arc length. So that's a major arc length. If I go all the way from A, I'm going now, that's a major arc length, going from A all the way to B. So that's a major arc length because it's bigger than that one. But if I go from A to B in the opposite direction, so I'm going for, but if I get to A to B in the shorter route, so that will be the minor arc length. So AB in red is the minor arc length. So the green part is the minor arc length, a major arc length, and the red part is the minor arc length. And that minor arc length is generated by an angle called theta. So that's the angle that generates that one. And the angle here, let's call that alpha, generates the green one. So that angle alpha generates that one. But the circle now has been divided into two portions of a sector. The green, if I write the green, A, O, B, A all the way to B, A, O, B, the green part is the major sector. So that's the major sector. So major sector, and the red part will be the minor sector. A, O, B, the red one. So A, B, O. That's the minor sector. So that's the minor. So a minor sector has a minor arc. So this is arc length for the minor, and this is the arc length for the major. That's a major arc length. It's generated by the alpha, and the minor arc length is generated by the theta. So that's important to know before you started on the arc length the definition we're talking about. So if we talk about the minor arc length AB, first of all, if you look at a circle, the arc length of a circle is what you call the circumference of a circle, and that circumference of a circle is the arc length of the whole circle, and the angle in the whole circle is 360 degrees. So that's 2 pi r created at 360 degree. But r, this is r the radius, and that's r the radius. So r is the radius. Any distance from the center to any part of the circumference will be a radius. Now we can generate a relationship here. So the relationship is the circumference of a circle divided by its angle is equal to the arc length divided by its angle. So that's the story. The story is that we say the circumference of a circle, which is 2 pi r, divided by 360 degrees, will be equal to the arc length. It depends which arc length you're looking for, that one or that one. So let's keep that one. The arc length L of the smaller circle, of the smaller angle, divided by that angle theta. So that's what you could do it for this one as well. It will be L over alpha. So that's how you generate the formula, and that is what we're now going to use to derive the formula for arc length. So the arc length is the distance generated by an angle theta. The distance is from A to B, because if I move A from A all the way to B, I'm generating that angle theta. So therefore, I can say this is what we now need to do is remember that 2 pi is equal to 360 degrees. So I can rewrite that story here. The story is that we know that 2 pi is 360. So I can say 360 times r over 360 is equal to L over theta. So remember, the ratio is that the circumference of a circle divided by its angle is equal to the arc length of a sector divided by its angle. So that's what we've done here. Circumference divided by the angle, arc length divided by the angle. Remember, circumference is the length. So now we can see that 360 cancels 360, and we're left with the final r is equal to L over theta. Okay, if that's the case, you can see now, it's easy to see. Take the L divided by the angle, so L divided by the angle is equal to R. R is L over angle. Or you might say, if you write that out properly, that could turn out to be L. That implies that L, the arc length is the distance from A, between A and B. So that distance is arc length. That distance equals R theta. So that's the formula we need for arc length. So it depends which arc length you're looking for. If you want to find that one, this one here, it will be L, that one, divided by alpha equals R. Or if you're looking for the arc length here, it will be L divided by theta equals R. Or you might say L equals R times theta. R times theta, that'll be L. Or this L here will be L equals alpha times R. So that will be L theta. So that makes sense. And if you have L alpha, it will be R times alpha. So that's what you need to understand in terms of arc length. See if I just move that up a bit now and put it that way. So that's your arc length. And that's the formula for them.